Hi all, we are going to start the second module and this will be the first part of module 2. And today we will discuss about physical vapor deposition or PVD process. Okay, there are different types of deposition process in order to coat a thin film over the substrate. One such process is PVD or physical vapor deposition. It is the physical ejection of materials as atoms or molecules and condensation and nucleation of these atoms onto the substrate. That means we will have a base material, then we are agitating by some form of energy. It may be thermal or laser or electron beam or even current. Due to this energy, the base materials get vaporized or it is releasing atoms or molecules. That ions or molecules can deposit onto the substrate. Simply we can say PVD is a process of transferring substance from a source and depositing on a substrate to form a thin film. The thickness of deposited layer can control from 0.1 nanometer to some millimeter size. PVD from gas phase is subdivided into 4 groups, mainly 4 groups. First one is evaporation, then sputtering, then laser ablation, and the fourth one is ion plating. First one is evaporation method. It is one of the simplest deposition process. Okay. In this process, the material you want to deposit is vaporized by means of thermal energy. The source material is deposited onto the substrate to form a thin layer. Check the figure. There is an evaporation source and this is the substrate where we are going to deposit the vaporized material. In order to avoid unwanted chemical reaction, the entire unit is placed in vacuum. The source can be heated electrically by a resistor or using an electron gun. In order to get a uniform thick coating, we can even rotate the substrate at particular RPM. Normally, this process is carried out at low pressure because the mean free path will be very large at low pressure. Mean free path is the average distance travelled by a molecule between two successive collisions. At this pressure, the atoms and molecules in the vapor phase, it will not collide with each other. In practical way, the collision will be negligible. Even though it is a simple process, there are some disadvantages. Here the evaporation of compounds is very difficult. It will be very difficult for those having high melting point. Then these compounds may undergo some chemical reactions at high temperature. And sometimes the film, that is the deposited film, will not be uniform. Next one is sputtering method. Sputtering is the removal of surface atoms or molecules by the surface bombardment or collision with energetic ions. Here the ions hit the solid target and knocks out the surface atoms, and these knocked out atoms are deposited on the top of substrate and it will make a thin layer. See the figure? We are putting certain kind of potential difference in between the cathode and anode. Then we are injecting certain kind of plasma over there. The plasma, it is due to the ionization of heavy inert gas like argon. They are hitting onto the target materials, that is the source materials. Then the atoms or molecules are coming out of the target. It is due to the collision and it is depositing onto the substrate materials. So that's why it is called sputtering. Please note, for efficient momentum transfer, the atomic weight of the sputtering gas should be close to the atomic weight of the target. Otherwise, it will be very difficult. Okay. Mainly there are two types of sputtering methods, DC sputtering and RF sputtering. In DC sputtering, a DC voltage is applied across the electrodes to emit electrons and it will ionize the gas or it will produce sputtering gas. In RF sputtering, the DC voltage is replaced by RF source. Here, the RF field is applied to generate plasma between the target and the substrate. Now we can compare the evaporation and sputtering process. Generally, the sputtering process, it is carried out at high pressure in order to maintain ionization and deposition. So in sputtering, there will be series of collision. Comparatively, the sputtering technique will produce smooth and thin films. And the main advantage of sputtering is that those materials have high melting point can be easily sputtered. In evaporation process, it is very difficult, those having high melting point. And in sputtering technique, the deposited film will have better adhesion on the substrate than evaporated films. Okay. Next one is ion plating. It is also called as ion assisted deposition, IAD, or ion vapor deposition, or IVD. Here we are using target materials so that the target material is forming certain kind of plasma. That plasma can hit the target materials, then atoms or molecules directly go and deposit it onto the substrate. Here we are directly creating plasma by the arc cathode method or something like that, and then that plasma itself is depositing onto the substrate. There are two types of ion plating process. First one is plasma based ion plating. Here the bombarding species are generally the accelerated ions from plasma. Another one is vacuum based ion plating. Here the bombarding species are accelerated ions from an ion source which is kept in vacuum chamber. A typical ion plating system is shown here. There is ion source, there is an electron magnet. It is used to select the desired ions and it will act as a filter. Then the energy of these ions, it is controlled by an accelerator. Then it is focused using charge plates and directed towards the sample. Okay. The last one is laser ablation. The deposition through evaporation by laser is called laser ablation. Here the target or the source material is evaporated with the help of laser beam. Here high power pulse laser is focused onto the target and it is ablated to form a plume of atoms and molecules, and it is directed towards the substrate and there will be deposition. Application of laser can be continuous or pulsed. Pulsed means there will be an on or off mechanism. To increase the power, we will use pulsed laser. This system is pulsed laser ablation. Here the intense laser beam is absorbed by the target and the vaporization will happen. Actually, the momentum of laser beam is transferred to the target and it will eject the particles from the surface. This is called collisional sputtering. And this will create the plume of atoms or molecules. It is again ionized by the laser beam and this is plasma. And these ions will be deposited over the substrate. These are some of the benefits of other film deposition methods. Fast response, well controlled deposition rate, relatively high deposition rate, growth is independent on environmental factors, can be used to deposit multiple layers. We can even deposit highly crystalline complex films. We can easily make dielectric or thin ferroelectric films. There are also some disadvantages. It is complex system design. We need to select particular laser wavelength for each target materials. There will be high defects, uneven coverage, and it is not well suited for large scale film growth. Okay, we have discussed different types of PVD process. And these are some important questions you can note down. In the next session, we will discuss about CVD process or chemical vapor deposition. Okay, thank you.